Hey there, welcome to Pomodoro Joe for Saturday, November 4th, 2023. Let's take a look at LeetCode problem 1503. Last moment before all ants fall out of a plank. This is a medium problem. So we have a wooden plank, or a log. So we have a wooden plank of length n units. Some ants are walking on the plank. Each ant moves with a speed of 1 unit per second. Some of the ants move to the left, the other ants move to the right. When two ants moving in two different directions meet at some point, they change their directions and continue moving again. So if an ant moving left meets an ant moving right, they will turn around and move the opposite directions. The ant moving right will go left and the ant moving left will go right. Assume that changing directions does not take any additional time. When an ant reaches one end of the plank at time t, it falls out of the plank immediately. Given an integer n and two integer arrays left and right, the positions of ant moving to the left and to the right return the moment when the last ants fall out of the plank. All right, so to summarize all this, we have a plank or a piece of wood of length n. We have some ants on this plank. The positions of these ants are listed in left and right to start with. The ones in left are moving to the left, the ones in right are moving to the right. Now when an ant moving to the right meets an ant moving to the left, they'll turn around and go the opposite directions. And our goal is to return the time, an integer, when all of the ants are off this log or plank. All right, and we have an example here. So n is 4, left we have 4 and 3, and right we have 0 and 1. Okay, so at 0 and 1, these two ants, they're moving to the right, and these two ants are moving to the left. All right, so after 1 unit of time, let's see, the guy at 1 is going to be at 2, and the guy at 3 will also be at 2. So then they switch directions. The guy at 3 will go back to the right, and the guy that started at 1 will go back to the left. So let's see, they switch directions, they keep going, so on and so forth, until all the ants are off this log. All right, so one way we could approach this, we could actually set some time, t equal to 0, and then we could actually update our time. We could have a while loop that goes time 1, 2, 3, 4, and then we can go through every ant in our left and every ant in our right, update their positions by either adding 1 to the ants moving left or subtracting 1 from the ants moving right, updating all their positions. When we find two ants that are in the same position, so we'll actually have to go through and look for these like collisions. When two ants are at the same position, we can flip their direction. So we can move the ant that was moving right into the left, and we can move the ant that was moving left into the right, and keep going up until all of our ants are empty, or both of the left and right arrays are empty. Now that sounds like a lot of work. And one thing I noticed in this diagram, let's go here. So we have some ants moving to the right, some ants moving to the left. So at time 1 here, two ants are meeting. Now is this ant at the top, so these two ants are at the same position. Is this ant at the top the one that was moving to the left and it just hasn't shown the direction change yet? And is this ant the one that was moving to the right and it hasn't shown the direction change? Or does this show the direction change? And this ant, the one that had been moving to the right, is now moving to the left. And this one is the one that was moving left and is now moving to the right. So I think this is illustrative of one key concept, and that is it doesn't really matter. The point is, when two ants meet at some position, position 2, one of the ants will change direction and go back the way it came. The other ant will change direction and go back the way it came. And if we were keeping track of individual ants, like this one shows this is ant B, I guess. So this was the one that was moving to the right and now it's moving left. Now, if we kept track of individual ants and their identities, then it would be important to sort of do this whole flipping them around. But the point is we don't really care about which ants are moving left and right. We just care that an ant is moving left or right. So at this point in space, at this position 2, two ants enter, one moving left, one moving right. And two ants leave, one moving left and one moving right. Now they happen to be sort of flipped, it's the opposite directions, but we don't really care. We just know that two ants entered, one moving left and the other moving right, and two ants leave, one moving left, the other moving right. So instead of keeping track of individual ants, we can just keep track of the general direction of ants and ants at positions. So this just means we don't actually have to do all the simulation of all the ants and all their flipping. All we care about is that two ants entered this position and two ants are leaving this position. One moving left, the other moving right. All right, so let's put 25 minutes on our Pomodoro timer and we will get started. Now, because we don't care about actual ants and individual ants, we only care about the movement of ants left and right. What's the longest it's going to take for an ant moving left to reach the end of the log? So yes, it might bump into another ant and switch directions, but that other ant will also switch directions at that same position. So we can just imagine it's the same ant continuing on from that point. So what is the longest it's going to take an ant moving left to reach the end of this log? Well, if an ant is moving left, it needs to go from the index that it's at down to index 0. So because it has to go from the index that it is at, the position that it's at, to index 0, it's going to take that many units of time. So then what's the longest it will take for an ant moving left to reach the end? Well, it's going to take the maximum index time. So let's see, we'll call this like longest left. So the longest left time. Well, the longest amount of time it's going to take for an ant moving left to reach the end of this log or the end of this plank, that's just going to be the maximum index. So we can just do max of left. All right. So we just find the maximum position of our ants in the left array, and that will be the amount of time it's going to take that ant to reach the end of the plank. So that's the longest left time. So that's the longest left time. What's the longest right time? Let's do this. The longest right time, well, it's a little bit different. Instead of moving left, our ant is moving to the right. So it's going to go from index 0 or some index to the right, and it has to reach index n. That's the end of the plank on the right. So for this, our ant has to go from some minimum index, let's say it's 0, all the way up to n. Well, that's going to take n units of time, n seconds. Now, if the ant starts at index 1, it is one step closer than the ant that starts at index 0. So this is going to be n minus 1 units of time. If an ant is at index 50, it's going to take n minus 50 units of time, so on and so forth. So for the right side, this is going to be n minus the minimum value. We want to find the smallest index where the ant might start. So this will be n minus the minimum value in our right index. So now we know how long it's going to take, or the longest it's going to take for some ant moving left, or all ants moving left, to reach the end of this plank. And we also know the longest it's going to take for all the ants moving right to reach the end of the plank on the right-hand side. So then how much time will it take for all the ants to be off this plank? Well, that's just going to be the maximum of either the longest left time or the longest right time. So we just need to return the maximum amount of time it's going to take, the longest left or the longest right. So we can just return the max of the longest left time or the longest right time. All right, and this should be it. So let's see if this works. All right, so we got an error here, and that's because I'm taking max on an empty list. I didn't look at my constraints. I should have done that. Let's look at constraints here. So n is between 1 and 10 to the 4th, but left can be between 0 and n plus 1, and right can be between 0 and n plus 1 as well. Okay, so these could be empty, so we better check to see if they're empty. Let's do that. We'll take max left if we have a left. Else, it's going to take 0 time. Same thing on the right. We'll take min right. Let's see, I'm going to wrap this in parentheses just so we have the right values here, right order of operations. That's if, right, else, 0. All right, let's try this again. All right, so that works. Let's see if we can pass all the tests. And we pass. Let's see, we do pretty well actually. Wow, we beat 95% for runtime and 31% for memory. So this is fantastic. All right, I don't think I can improve on this. So I really like this solution because it's pretty straightforward. It looks pretty clean, like you can understand what this means, longest time left, longest time right. Now, if you really want to be fancy, we could cut this down into an even smaller solution. So this variable here, we're using here, we could just replace it like this, putting it in here. And then we could replace this one with this. So we can just grab this, put it in here. And then we can just remove these, and now we have a one-line solution. Now, I like the previous solution better just because it's clear what's going on. But if you really wanted to sort of be fancy and cut this down so it's on one line solution, you can do this. Let's see if it still works. Yep, still works. See if it's any faster. I doubt it, but we'll see. And it's significantly slower. So we went from a 95.4% for runtime down to a 38% for runtime. But we do much better in memory. We went from a 31% memory up to an 89% memory. And that's probably because we're not keeping track of these local variables, these left and right longest times. All right, well, I think that's it for me. This was a super fun one. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.